Hitchner Manufacturing Company de Mexico, a subsidiary of Hitchner Manufacturing Company of Milford, New Hampshire, is a Tier 1 supplier of high-volume machined and assembled metal form components for the automotive industry. Located at the Tres Naciones Industrial Park in San Luis Potosí, Mexico, 400 kilometers north of Mexico City, the newly constructed 50,000 square foot facility is designed for lean manufacturing techniques, utilizing state-of-the-art manufacturing equipment to reduce cost, maintain the highest levels of quality, and meet customer requirements. Hitchner has the engineering and process expertise to assist in component and assembly design. Company engineers both in Mexico and the United States work closely with customer counterparts to define the requirements and design assemblies and their components for economical manufacturing. Every employee completes a vigorous classroom training regimen encompassing safety, work instructions, quality system requirements, statistical process control, total productive maintenance, company policies, as well as task-specific training. Daily shop floor production meetings where open communication is encouraged create a team spirit and provide a clear line of sight between business objectives and employee jobs. Hitchner Manufacturing Company de Mexico manufactures and ships product according to just-in-time schedules while maintaining minimum inventories by following lean manufacturing principles. Each morning, the production scheduler securely logs onto the customer website and reviews the daily requirements. Actual production is set to match these needs exactly. Hitchner's suppliers were in turn selected with consideration of their ability to deliver just in time. For the rocker shaft assemblies, high-quality investment castings are transported from Hitchner's world-class foundry in Santiago Tianguistinco, Mexico, 500 kilometers to the south. First in, first out scheduling is the rule throughout the process and applies to raw material as well as finished product. Throughout the process, intake rocker arms are handled and processed separately from the slightly different exhaust rocker arms. Production work center resources are utilized to prevent bottlenecks and minimize buffers while enhancing throughput and efficiency. At one end of the facility, production begins on the castings with boring and facing operations. Here, the internal diameter of the rocker arm is bored and statistically controlled to within 80 microns with CNC lathes. A highly specialized rotary CNC machining center mills and drills the rocker arms, adding the required oil holes for lubrication of the valve pallet and pressurization of the hydraulic lifters. The critical pushrod socket geometry and surface finish are also imparted to the castings at this operation. A pick-and-place robot is used for loading castings into the fully automated machine and locating the parts on the previously machined boards. 9 operations, including automated gauging and deburring, are performed on the exhaust rocker arm and 12 on the intake rocker arm. A tool monitoring system is employed to detect tool failure and wear, thus preventing the production of defective parts and enabling optimization of tool life. User-friendly Hitchner-designed gauges integrated into computers are used throughout the operation to facilitate statistical process control. Additionally, error-proofing devices called pokeokes are used extensively to ensure that production always remains well within tolerance and to maintain part quality. Hitchner quality processes have achieved a defect rate below 5 parts per million. A fully equipped lab is used to certify incoming raw materials and in-process components, using automated coordinate measuring machines and sophisticated surface analysis instrumentation. Inspection and calibration of gauges and fixtures is conducted with a full array of metrology tools. At the next step in the process, a heat treat operation enriches the part surface with carbon and hardens it to provide wear resistance and increased strength. Special baskets are utilized to prevent contact damage and to ensure uniform surface exposure to the process. After carburization and hardening, the parts are washed to expel the oil. A tempering oven then conditions the parts by removing residual stresses, providing the desired mechanical properties. Metallurgical inspection of part microstructure is conducted on specimens from every heat treat batch to ensure performance of the computer-controlled cycle and compliance to specification. No-touch policies are used throughout the facility to eliminate the consequences of handling damage to functional surfaces. This is accomplished by the use of custom-designed material handling equipment and the construction of fixtures so that parts are not clamped, located, or transported with contact to those critical surfaces. The honing operation is performed on an indexing rotary machine with 16 spindles. Multiple single-pass hones use diamond grit to produce the required roundness, surface finish, and tolerance, with successive passes of increasing precision and reduced stock removal. Air gauging is integrated with computers for process control. A grinding operation brings the valve pallet to precise tolerances, measured in single-digit microns, while achieving a CPK of 2. The surface finish is also enhanced, reducing operating friction and thus wear of the mating parts. After the castings are run through a final cleaning operation where they are washed, rinsed, and treated with a rust preventative, they are processed through an automated gauging machine. This 6-position auto gauge checks 8 critical features on 100% of the rocker arms, using a combination of air gauges and linear transducers. A small steel ball is inserted to plug one end of intersecting oil holes. The insertion force is automatically monitored to ensure the correct fit. Defective parts are automatically marked and rejected through a chute into a locked scrap bin. As the rocker arms are being processed, Hitchner's supply chain management ensures that raw materials for the shaft and other components are received according to production requirements at the opposite end of the facility. The tubing is moved to a cutting station, trimmed to length, and the outside diameter is chamfered. The straightness of each section is verified as they're loaded into a 6-station trunnion machine. Both ends of the tube are internally bored and chamfered, and an orientation slot is milled into one end of the shaft in this operation. Automated drilling machines cut 22 holes in the shaft in 2 operations. The holes are completely deburred within the process. Tool detection is employed to prevent processing shafts using broken drills. The shafts are hopper-fed through a centerless grinding operation on a belt conveyor. This operation grinds the outside diameter to a tolerance of 25 microns. This diameter is 100% auto-inspected, and the size automatically controlled by instantaneous feedback to the machine computer. A high-pressure wash operation thoroughly cleans the parts and expels any processing debris and loose burrs. The shafts are no-touch loaded into heat treat baskets with the use of protective plastic sleeves. The highly finished outside surface is thus protected from scratches prior to hardening. A vacuum heat treating oven immerses the shafts in a controlled atmosphere of nitrogen, carbon dioxide, and ammonia to impart a precisely hardened nitride layer. Specimens from each cycle are analyzed in the laboratory and must be certified before the parts are released for the next operation. A final deburr and hole presence and location verification operation auto-loads the tubes into a final washing operation that cleans the shafts and applies a rust prevention solution. At the assembly operation, the process shafts are mated with the finished rocker arms. A rotary index table equipped with several checking and poke-yoke stations is used to automate the process. Rocker arms and spacers are first loaded into a fixture. The shafts are automatically inserted in their proper orientation. Next, the rocker arm rotational torque is measured. If the rotation is not proper, the machine stops and alarms. At the next station, the eyelet and shaft retainers are assembled. The bolts that are used for final assembly onto the engine head are inserted and held in place by the special eyelets. A poke-yoke is used to prohibit assembly with damaged bolt heads. End caps are inserted into the shaft ends, and a date stamp is applied for traceability. A leakage test is next performed to verify the integrity of the shaft end sealing. The assemblies are machine marked to indicate that they have passed this test. They are then visually inspected and loaded into color-coded, thoroughly cleansed dunnage. At the customer's engine assembly plant, the completed rocker shaft assemblies are simply removed from the customized dunnage and bolted into place. Hitchner Manufacturing Company de Mexico. Engineering expertise, unsurpassed quality, supply chain management, innovative technology, proven systems, high volume capacity, ready to meet your needs.